Okay, so we're going to look at logic gates again today. So it's the same objective and the same success criteria as last lesson. So as we know, the three main construction gates are NOT and OR. But the other gates used are NAND, NOR and XOR. And these are the ones we're concentrating on today. So the NAND gate. Now the NAND gate, this is short for NOR AND. Okay, so it works differently from the AND gate. Sorry, not AND, not NOR AND. Okay, so if both the outputs are false, and then this will be true. So if both of these are 0, so if you've got 0 here and 0 here, then the output will be 1. Okay, but if you've got 1 here and 1, then the output will be 0. Okay, because it's got a not in it. Okay, now if the output here was 0 and 1, then the output here would be 1. Okay, because it does the opposite basically of the AND. That's the way you need to look at it. Right, then you've got the NOR gate. So the NOR gate is different from the OR gate because this has got a not in it as well. So if, now with the NOR gate, it's always true if one output is true. Okay, so with the NOR gate, if we was to use this one, like so if both these inputs, because it's got a not in it, so if both these inputs were 0, then the output would be 1. Okay, but then if this was 0 and this was 1, then the output would be 0. Okay, because it's got a not in it. So it has to have both, and if both inputs are 1, then this will be 0. Okay, so the XOR gate. Now, this is arguably the most useful gate, okay, because its circuit can be applied to so many different computational circuits, such as error detection. So, now this gate works if basically what happens is both these outputs here, inputs were 0, then this would be 0. And if one of these inputs were true, then this would be 1, okay, or true. And if both the inputs here were 1, then this would be 0. Okay, so it says if any of the outputs are true, then the inputs are true. Okay, but if the inputs are true, then the output is false. Right, so what you're going to complete now is, so you've got, help with this, is you're going to complete the truth tables for the NAND gate. Now the link to this task, okay, is underneath the description on the video. Okay, and so if we go here and I go to truth tables, here we are. So you're going to complete the truth table for each of these. Okay, so remember this is the NAND gate. So what we're going to do is please start logically by filling in 0, 0, and then 0, 1, and then 1, 0. Then obviously what's left is 1, 1. Okay, and then remember, so because it's got a not in it, so the output's going to be the opposite, so this would be 1. Okay, right, so obviously pause the video now and please complete the task. Okay, welcome back. Hopefully you got all of those right. I'm just going to clear this here now. Okay, right, let's take a look. So obviously I've got the answers to all the tasks afterwards, so you can check. So these are the answers for the NAND gate. Please compare your answers. And the XOR gate. Please compare your answers. Pause if you need to. Then we've got the NOR gate answers. Please pause if you need to. Please compare your answers. Okay, so you're going to need to refer to these during a lesson. So now what I'd like you to do is complete the simple exam question on the Google Doc. So in the description underneath this video, the simple exam question is here. So now the simple exam question is here. So it's Rajesh creates a logic circuit, uses 3 different gates on his circuit, and then it's basically it gives a statement to describe the logic gates. And then here you write the answer and draw the logic gate. Obviously, I understand if you're on a computer, if you can't draw this on a computer, it's no problem. Please just draw it on pen and paper, and it's absolutely fine. Okay, Right, so pause the video now and complete that question. Back, I hope you're confident with your answers. So, here are the answers. So the first one was an AND gate. The next one was a NOR gate. And then this one was the NAND gate. So I hope you got that right. So as you can see, with the mark scheme here, it's one correct mark for the name and one correct mark for the symbol. Okay, so it's 2 marks per question. Next. Okay, so interpreting circuits. So what we're going to look at now is we're going to look at how we actually interpret these circuits. Okay, so how do we figure them out? Now, you're going to complete exam question 2. So firstly, before you complete exam question 2, I'm just going to explain to you how you interpret the circuits. Right, so what you do is we need to basically just look at how this works here. So you can, for example, draw this on pen and paper. So so for example, what I would do is that I would just get my pen and draw. So I'm just going to get this up here. This isn't ideal, but it will do for now. So over here, I would say, for example, I would put this as 1. And, oh, that's not very good. No, I'm not going to do it that way. Sorry, I'm going to do it this way. So here, if I would put this here, A as 1. Okay, and then here, I would make this 1. And then here, I would do the same here. Then I would basically see the outcome of each of these. So, for example, like we know this is a NOT. So we know that this is going to be 0, the outcome here. Now we go from B here, which is 1, over here, to the OR gate. So we know B's 1 here. So here, I would put this as 1, obviously, because that is the correct answer. And then here, right, here I would move this over here. So we know this is an OR gate, correct? So then over here, we notice the input here is 1 because it's already there. So, and then we know the output here is going to be, is going to be 0, okay, because it's a NOT gate. Sorry, this isn't ideal, I know. Right, so we know this is a NOT gate. So we know the output there is 0, but we can move this output over here, okay? So, now, next, this is an OR gate. So we know this is going to be 1, because only one of the inputs needs to be true to make the output true. So now we've got to figure out our output here. So we know this is 1. So in fact, I'm just going to pick this one up. And I'm just going to move it over here, just be easier. Okay? Right, and then now we need the output. So this is an AND gate, right? So there has to be, both inputs have to be 1 for the outcome to be 1. So we know that the outcome here is 0. So I'm just going to copy and paste this over. Okay? Right, now, so now what I can do is I can just move both of these over here, because we know where they're going. They're going here. Right, now this is an exclusive OR gate. Now the rules of an exclusive OR gate are, so this is why you need to know your rules, is if you've got an input of 1 and 0, okay, then the output is 1. So now we know the overall output is 1. So that's how we interpret our gates. Okay? Right, so now you're going to create a circuit yourself. Okay? Sorry, no, you're going to do exam question 2. I apologise. So I'm going to go to exam question 2 here. Here's exam question 2, which we've just kind of been through. So what I'd like you to do is interpret that circuit and complete the truth table. Okay? So that's all you have to do, and then I will go through the answers with you. Okay, pause this video now. Welcome back. So firstly, the first thing I would do, obviously, is I would fill these up logically, how they would be. So this is how you would logically do this. So 1, 1, 1 here. Oh, apologies. 1, I think 1, 1. Okay, so we're filling the truth table. So I'm just going to go through the first. So logically filled. No, I've not done that logically, really. Okay, I'll just go through the first ones and I think you'll get the answer, the idea. So firstly, all of them are going to be 0. All of these are 0. Okay, so if this is 0, that's going to be an outcome of 1. So we've got 1 going in there. Okay, then if this is a 0, then that is going to be 0 and 1. Okay, and that's an OR gate, so that can still be 1. Okay, so we know 1 is going here. That's what's happening. Then here, this is 0, so the outcome there is 1. This is 0, so the outcome there is 0. So there's 1 and 0 going into the AND gate, so that's going to be 0. So in the XOR, 0 and 1 would be 1. So we know this one, the answer here for X is 1. Okay, so that's how you're going to check your own answers and make sure that that is correct. Right, so moving on now. Now, your next exam question, okay, is going to be, you're going to create a circuit using these, okay? Now, the rule is, if you remember from last lesson, is it goes not and or. So you create a circuit with nots first, then the ands, then the ors. So the ors always come at the end. Okay? The only rule is that the brackets will come first. Okay? And you can see that there's brackets, but sometimes the brackets don't necessarily always make a huge difference. So we're going to go through this first. Now, so as you can see, this is exactly the exam question you see there. So firstly, because remember, it always goes not and or, I've highlighted the ors here. Okay, so B is 1, or is C is 1. Okay, then there's the nots. So firstly, we put in our nots. Then you put in the ors. Okay, so you can see the ors go here. So there's 2 ors, 2 nots, 2 ors. Okay, so you can draw those in first. Then you've got the ands, and the ands always go at the end, pretty much. There we go. So that's how we build it up. Then, from there, we start putting in our junctions. Okay, so, and the junctions are based on the statements, as you can see here. So this is how I would join those together. Then you can see that the next statement is here. So I would join them together. Then we've got the B is 1 or the C is 1. So then I would put those junctions together. Then at the end, after that, you can see that there's just a junction with the ands right there. So we just simply join the remaining gates. Okay, easy as pie. Now, if you don't get it right the first time, do not worry, because everybody takes a different speed to get used to this. Okay, so don't worry too much. So what I'd like you to complete now is exam question 3. So exam question 3 is right here, okay, and it's basically you need to draw the circuit with this corresponding gate. Now please remember the order is not and or, and you put the brackets first. Okay, so not and or. Now please take your time, and like I said, if you don't get it correct, don't worry. All right, and like I said, you can do this with pen and paper, it's not a problem. Please pause the video now. Okay, so you would have completed question 3 by now if you've clicked back on the video. And like I said, if you found it confusing or hard, really do not worry about it. You know, I've taught this before, and you know, different people take, you know, some people find it very easy, some people find it very hard, but we all get there eventually. Okay, so if you got it right, brilliant. If you haven't got it right and you wasn't sure, then don't worry, we'll get there one day, and don't worry, we'll be teaching these in class. So now here's the answer. So this is the answer. So as I said, we start with the NOT gates, and then we need a junction to go from this NOT gate to connect to the AND gate, because the AND gates have to have 2 inputs. Okay. Now sometimes the most confusing thing, especially when I was practicing these myself, is where to put the junctions at times. But if you go along the lines of, you put your NOT gates first, then you put your OR gates, then you put your AND gates, and sometimes it will finish with an OR gate because it depends on the exam question. Then, sometimes the hardest thing is connecting the junctions. But don't worry, if you got it right, well done. If you need work on that, that's fine. We'll be working on it. There's no problems with that at all. Okay, so now moving on, this is the last exam question I'm going to get you to do, and it is an easy one. Okay, I think most of you would have mastered the truth tables by now. Okay, so we're going to complete that one. Now, this is exam question 4. Here we go. And here's your exam question. So here's the logic circuit as shown. And remember what I said. Okay, do it logically first. Okay, so you put your zeros in first and so on. Okay, I'm going to delete that. Then down here, we've got the next one. Explain the difference between the functions of the... Sorry, that was just some notes I put there. Between the functions of the AND gate and the OR gate. 3 marks. Okay? Right, pause this video now and complete the question. Welcome back. Okay, so complete question 4. So, now, here let's go through the answers. So, it says 4 marks for 8 correct outputs. So, these are all your outputs that you should have put in. And then 3 marks for 6 and so on. So, 0, 0, 0 would be 1, 0, 0, 1 would be 1, 0, 1, 0 would be 1, and so on. Okay, so you'll get 4 marks for all 8, 3 marks for 6 or 7, 2 marks for 4 or 5, and then 1 mark for 2 or 3 correct. Okay, now any free from, if the AND, output for the AND, if both of them are 1, then if both of the inputs are 1, then the output is 1. Okay, if both the inputs are 0, then the output is 0. For the OR, if either one of them is 1, then it's 1, and so on. Okay, and 3 marks for that. So if you basically wrote out the rules of the gates, you would have got it right. Okay, now, I hope that you have learned something. And like I said, I do understand that not all of you are going to feel confident right now. But don't worry, it comes with practice. You just get used to it. You just get to understand it and it becomes easier. Okay, best of luck, and I will see you next week.